See where this goes. This one goes. Just been doing. Well, I mean, I guess I've been seeing a lot of the transformer, the Faraday transformer. The most sensical expression of this transformer was just the marbles. If you fill the marbles up, um, and they just go, you just have marble, 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 and just loops and loops and loops of. I know loops aren't good, but just this matter, this frequency that is, whether it's doing uh, the torsion, um, like the twisting, or I don't exactly know. String theory just seems to say that it's more, yeah, that there'd be bits connecting to the neutrons and bits connecting to the electrons. So that's pretty difficult to uh, do your logical deduction with. Um, Essentially, like any of those things. But yeah, I mean, just marbles, and you push one marble in, and another marble pops out at the end. You put one marble in, and another marble pops out at the end right away because there's just that many marbles that are compressed, and so it's this pressure. Um, Obviously, there's a problem with gold. Supposedly, that's the only dielectric metal, and you have the uh, the copper and the silver, which are the copper is substantially less magnetic than the silver, meaning that it would just have a much uh, lower frequency. The frequency is moving slower than the metal. Um, so we were saying that the frequency is lower because it has less bits. That means there's more uh, matter. Sorry, there's more frequency in. There's more. Uh, there's a higher frequency in nickel, um, because nickel or iron or these types of things are going to be more magnetic. They're just going to have this higher frequency, meaning that there's going to have to be more compression, more pressure. So they're more pressurized, um, and that's going to be the oscillation or the Faraday paradox, where um, there's an exit and then, or sorry, there's an exit and then something re-entering, like a very little bit of energy re-entering. So, I mean, I don't uh, hesitate to understand that just to be the direct current running out of frequency and uh, decaying and then entering back into where the copper is, the insulator, and just understanding even overall the electricity in the sense that yeah, it's not lightning bolts shooting through a wire, even though sparks fly if you do something wrong to an outlet, and yeah, I mean you gotta like really, you know, yeah, I mean, a lot of people wouldn't, I guess, comprehend that. It's not like the most easily comprehensible thing. I mean, unless you've done a lot of thinking. And so, yeah, when it comes to this Faraday paradox or torsion, um, the more the more compressed the so it's like saying the more pressurized the bits are, the higher the frequency is, and that means you'd have to have less of an not less of an insulator. Well, it's higher, it's lower voltage and uh, higher amperage. So the amperes law. So it's lower voltage, higher amperage, and that means that you're juicing the microwave. You're juicing the microwave more, and you're putting whatever combustion engine that you're putting into, is just going to be burning a lot hotter, meaning that the fan will be moving a lot faster in direct line with the oil. So oil oil will be taken out faster. So the oil would be taken out of the generator faster and have a higher force, a higher centrifugal force on the fan, and of course, there'll be a unit like that just the spark like a essentially like a spark plug. So at the end of the spark plug, that's what you'd have to keep clean in your car. And so when you fire that ignition, uh, the spark plug is hit, or the spark plug has you know it's flinted. It's like a flinted mechanism, so it creates the fire. It creates the heavy hydrogen helium fire, and then that starts decaying. But before that happens, it's able to hit the insulators and insulate enough, whether it's the rubber, or the copper, and that insulation goes through and hits that insulator, that magnetism goes through and hits uh, more magnetism or magnetic plate, and then heats the magnetic plate enough to where there's going to be a gravitational sway, like a north-south sway or an east-west sway on the like on your compass, essentially magnetically, and that sway is going to be converted. Well, that energy is going to be converted into the fan. So now you have your magnetic uh, current, which is your you have your anode and your cathode, and then that fan is going to start hitting centrifugal force, so it cools, um, and it also expires. Um, well, this engine. Okay, so this is your oil going down, and then that force is going to um, go through uh, more uh, insulation, and that magnetism will be uh, still insulated, and then that will be what goes out of your exhaust pipe. But it's just saying that, well, what's happening in the engine is you have you have your pedals, you have your gas pedal, and all you're really doing then at that point is uh, maneuvering how fast or slow you want the fan to move. So if you want the fan to move quicker, you put your foot on the pedal, you remove the insulator, it conducts more electricity, and that electricity then gets the energies, or or there's an energy conversion or transformation, and that spins the fan faster. It puts out more gas, and and yeah, and then your car starts, or you start moving, because all you're doing is moving one insulator, and the insulator moves the fan faster, and that fan um, that's connected to the magnetism is what is going to um, push your car forward. So it has to have it's like a really, it has to be a really big generator in your car. And so, yeah, all the way to the last molecule of oil. So, yeah, I mean, then there's the highway problem, or the kinetic energy. Okay, so uh, to go twice as fast, to go twice as fast, it takes four times the amount of energy. Now, everybody knows, well, not everybody, but we know that there's, the tall tale that you want to be on highways. Highways are better for gas because you get better mileage on highways. You get 40 on highways or 20 like in the city, and that's essentially saying that you use less gas going at higher speeds. Um, Now that's talking in miles. So what we're saying, I mean, what I guess the idea is, like, I'm just working with this. I mean, this is, I guess, heading back to the 1700s. And what I'm working with is, you know, yeah, okay, all right. So everybody's saying, you get better mileage on the highway um, than in the city. Now you're using now kinetic energy would say that you're using more gas. So the free energy, why aren't you using more gas? Or sorry, why aren't you using less gas when you are um, going faster, higher speeds? Essentially, one half the mass, and then you get two times the velocity. Um, so you're doing. I mean, it's just a plug-in. So it's not, I guess. Well, one half the mass. You're doing mv squared, and yeah. You're going. I mean, I've seen it a million. I mean, I've seen it a lot. But you're going. It's the paradox. So how are we saying that the car is using, or the car is creating? Sorry, the car is using four times more energy since you're using the velocity, and you're also using what you're doing here is using the oil. Because we're just talking about a smaller smaller amount of oil with more velocity. Um, so how do you essentially use less oil in the time it takes you doing 40 miles compared to 20 miles? Um, that's I mean, I don't know. It's just like, you gotta. I guess you got kind of got to think about it because I can kind of partially wrap my brain around it. Um, all right, and yeah, I would just say that. I mean, I would just say that we're talking about the magnetism. I mean, it has to come back to the magnetism. So when you go at higher speed, the fan's moving quickly, more. The fan's moving faster, so you have to be able to compress or put more pressure into the conduit, the electrical conduit or the magnetic conduit, and essentially just like an invisible form of energy, and that's going to be transformed into the fan and then out the exhaust. And here you are, like pedal to the metal, and you're saying, well, the fan's moving faster, but you're using less energy, and that's just because I would say kinetic energy on kinetic energy that uh, you have increased the frequency because you have compressed. Um, Again, you have what you have done is completely released the insulator on the gas pedal. So the insulator is the gas pedal, and when you put your pedal down, it lifts the insulator, and is that insulator when it gets released and you go full pedal to the metal, then there's going to be the highest frequency possible. Like say you're going to the highest frequency possible in your car, pedal to the metal, then that frequency is going to be more efficient at just controlling. That frequency is going to be more. I mean, because it's a conditional statement. I mean, that frequency is going to be deductive in terms of the whole speeding up magnetism just because you're releasing the insulator. So that insulator is able to particleize um, much more quickly than if you were just going through the town, getting 20 miles to the gallon. So you're getting 40 miles to the gallon because you're going faster, because you've essentially sped up the electricity. Now, I would say that it has nothing to do with the Faraday paradox. You're just talking about increasing you're talking about increasing the amperage, right, and lowering the velocity. So I think we got there, but I definitely had not gotten there yet. But you're talking about increasing. All it is increasing the amperage, and the only way to essentially increase the amperage is to add a quicker uh, conduit of electricity, meaning that there has to be an insulator somewhere because it's essentially going to be an alternating current, and that alternating current, because it has that insulator, like if you're just sitting there not and you don't have your foot on the gas, then there's no insulator. Put your foot on the gas, then it turns into direct current. So I'm saying you're just increasing that direct current, and that direct current just reestablishes its energy when it's moving at faster speed, so it's able to conserve more energy. It's able to conserve more oil, the car. So yeah, I did not think I would ever get that one. Like with the rocket ship, it's the same thing. It's just the oil. But yeah, like I said, I think we've gotten here. I mean, if you're just increasing the amperage, all you got to know is that you're increasing the frequency of the magnetism. So increase the frequency of the magnetism by releasing like a Faraday switch, or sorry, by closing a Faraday switch. If you increase that, then that increased um, energy or magnetism will, obviously speed up the rocket ship like to 1,000 miles per hour or whatever. But yeah, I mean, again, amperage. So the only way you do that is to have uh, alternating current. So I think that was all. I think that was all stated. Um, and yeah, I mean, I didn't really like have too many questions. I mean, that was probably just the hardest equation I figured out in my life, other than the Eddington the Eddington paradox or the Eddington experiment. And yeah, I mean, the fact that kinetic energy does work like that. I mean, I know it's about magnetism, and it's always about magnetism, and you can't create. I mean, we technically can't even create a hydro inverted star. Like we can't even convert a hydro pressurized form of this. Like I mean, it's above this dielectricity, just because. I mean, if you're talking about gold just has the uh, the toroidal, and then it has the perturbation. So it has um, like these. It has the flares. It has the flares of magnetism and everything, and then somehow it's being like there's an adjacent pressure down there. So that's what they say about gold. Um, and that is what also is said to be dielectric, and it is only gold is the only form of dielectricity. So, I mean, if we are talking about, because you don't really want to talk about mass and velocity there, because then you're talking about shape, and shape really are not objects in that sense, because you're creating you're doing like geometric unification. So that obviously doesn't work. But like in the bigger picture, um, I guess that's all you really got, because I mean, that's going to be really tough to string theory or torsion a or even anything like uh, Maxwell waves or whatever. Um, is just going to be damn near impossible to actually get anything like through that is I don't know, like computated, really, like artificially computated. I mean, so yeah, it just you can't believe anything. I mean, saying that they found robots that can create stem cells. I mean, stem cells come from living organisms, essentially. I mean, stem cells could come from fetuses. So, I mean, I'm not kidding about that. I'm not trying to be like insincere to anyone about that, but I mean, stem cells have to be essentially living organisms, and they decay over time. And the more they decay over the time, the less cost they are. So just because science or physics says that something has done something, they didn't create robots. Robots created stem cells. Like what? Like the knife is a robot now. Everything's a robot. Everything's like a Cartesian. Like everything's like a freaking Cartesian. I don't know, just like some Cartesian play going on. Because that really is. I mean, when it comes down to it, like that really is going to be the best theory, and it's gonna be like an elusive staircase theory or a topological theory. And remember, there's at least I think there is unequivocally four dimensions of topology. So they don't go into gold. They don't go into the perturbations, and that's when they do the bits and the orbits. The bits and the orbits. Oh, that was pretty funny, but not. So yeah, I mean, you're just not going to be able to create because you're almost talking about like with gold or with the dielectricity. I mean, if you want to talk about like the exhaust, because you're not even talking about that. You're talking about the insulator from the spark plug. So the insulator hits the spark plug, and there has to be. Well, I'm trying to think of like. I'm trying to think of like inflammatory. Well, like entropy. There has to be entropy and the cooling, and because then again, like cooling is creating, like everything's a paradox. Like the cooling creates matter, and the entropy decays it. I'll never be able to say that correctly. And so there's all these types of quality to the magnet, and when you get stuck on it, um, it's not reasonable. It's not reasonable to say that you're going to be able to have anything that pushes these opposing forces. Okay, so it's same, and I'm trying to push these together, and they just don't want to connect. But somehow there's the idea. There it is. Somehow there's the idea that in gold, this is going to be a lot like this is going to be a tight knit mechanism, and they're mining gold and everything like that. So it's like, oh, okay. Um, well, maybe that could just mean that gold was deeper in the ground than copper or silver. Gold was just a ton deeper, and when they finally got to it in 11,000 years or whatever, um, that's when they could have been thinking about these things, like because the further something goes down, the more pressure there is, and maybe there could have actually been a topological perturbation that was causing dielectricity in the gold. I mean, I'm just saying. I mean, it's no other option. I guarantee you that gold is deeper than um, silver, and silver is deeper than copper. Just because I don't even have to look it up. Just because, yeah, they're going to have more elemental mass, because mass doesn't equal weight. Essentially, in that case, mass equals shape. So that's a quantum mechanical, conundrum. That's a quantum mechanical problem. And like, how do you describe that? I mean, if you want to say that gold is heavier than silver, then that's fine. Gold is heavier than silver because there's more pressure, and that's why it can have a dielectric effect. I don't mind that. But to just say that mass depends on weight, okay, it has more mass. Um, and that's going to, like, that kind of just goes in line with Bohr. So when it goes in line with Bohr, you can't really hesitate. Because yeah, I mean, it's all there, and that, yeah, I don't even. I mean, that's, and then I was making the mistake of Schrodinger, where I'm saying, okay, I'm not actually looking at like a process of, well, whether it's diffraction, or why is the light in the double slit or the single impediment essentially diffracting. So I wasn't looking at it that way, but essentially that is because of the Schrodinger, and how there's like an elusive nature to the bits. I mean, I guess it probably wasn't intentionally made to be deceptive, but I think at the end, um, people will be decepted by it, just if they didn't understand a higher frequency of magnetism could possibly equal, like, enough utility to be able to send it in an obscure direction, like to send the photons in an obscure direction, because you are trying to understand how light uh, light fills up a dark room as soon as the door cracks. That's all you're doing. So you're either saying you are either saying that it's a reflection or a diffraction. Reflection being Cartesian, and then uh, diffraction being Schrodinger, quantum mechanical. And I don't know if that's how Young looked at it, but I know that his magnetic waves did show four sources coming from the elect the sorry four sources coming from, obviously, the bracket or the slits, and then a a point in the middle, and waves to outside. So like essentially a wave, like a I mean, I know those waves reach way out, but it's just showing that there's energy moving that way, or that there is, since it's covering up the middle, and light's essentially bending like that. It's only bending. Well, it can only bend because photons are so small that they have to touch gravitons, is what I presume they imagine. They have to get caught in the bits, and the bits have to actually move the photons. Now that's, I'd say, agreeable, but I mean, because you still have your points of, like, like your points directing here to your double maxima, and then your waves connecting out. And so it's the paradox again, because it's like, oh, well, is it reflection or is it diffraction? So when they say it's diffraction, they only show the path length difference, and that path length difference is just not persuasive, because they're doing the diffraction. So why do they even have to do the diffraction in the first place? You could say that's because, well, they are doing the quantum mechanics, and they are doing the Schrodinger. So I didn't know that, and I just pretty much realized that. So All right, and then yeah, I mean, I was just thinking about like oils, and they use all these essential oils, and they just like cremate plants or animals or like organs a lot of the times for cologne, and they stick all that into a blender, and then they have a liquid like an organ like whatever leaves like whatever it is flowers, and yeah, all that stuff is grinded, and then it's probably mixed with water and grinded some more, and then that's diluted, um, and then what you do is you just continually until you have enough. You just continually heat. You just boil it. You just boil it, and so again, when you boil everything, the frequency is going to turn, and the frequency is going to. Yeah, excuse me. Yeah, real quickly, I just wanted to finish on, yeah, like you just would heat the oil. You got all the extraction. You just heat it and freeze it. I mean, you're not heating it and cooling it. You're boiling it and then freezing it. Putting more in, um, boiling it again. Uh, so what does that, I mean, what does this, like, how does that build elasticity? I guess would be the question. Like, how does that build stickiness? How does that build a glue? How does that, transform the energy just by having shards of frozen water or shards of this the frozen liquid as it gets frozen and more like you can just say that it's like you're compacting it more because um, when you heat everything up, everything's going to expand, and you're saying, well, uh, the frequency has to slow down, but you're stretching it out, and then when you freeze it, everything's going to be condensed again, so the frequency is getting higher. So it's like you're just packing clay, and yeah, that's how you'd get like eventually more of a like a gooey substance. I feel like because again, there just has to be this paradox where there's the pull, okay, but this is the controlling the gravity, whether it's like an hourglass or whether it's like an hourglass and the walls are controlling the energy. If you expand if you expand those walls like you're heating it up, that just means that the matter bits are moving out. So the force bits are pushing in, and the matter bits are moving out, or essentially spreading out all over the place, and that causes. And you're not saying that there's the torsion, but it has to have torsion. So then the torsion is just um, giving you the the again the higher frequency out or the higher frequency in. You're just it's just torsion. So um, cre- uh, uh, you know, of course the torsion is going to be the greatest when you're inside. I mean, you can't break glass, so when the torsion is closest in the middle, that's when you're saying things are cooling and freezing. That means there's a higher entropy, and that means there's more torsion, so there's going to be more decay, essentially, a quicker decay, just because it's going from a liquid to a solid. Um, Now, maybe I've said in the past that solids decay the slowest, but I was really misinformed about the. I was uninformed about the frequency because I was considering the frequency how um, there would be a quicker decay rate just because, well, I mean, because you can kind of say that because what are you measuring in a liquid? You don't really know what part of the liquid you're measuring, so that's why there's more bits in solids. But since there's more bits, everything is crunched in. That means there's a higher frequency, and you're saying there's a higher frequency, so a quicker decay rate in solids, slower in liquids, and then the slowest in gases because air is such a massive mass. like space is such a massive mass, so it has the slowest decay rate. Um, so I was getting the frequency mixed up. I don't know why, because I nailed it on like the Young thing. I knew that like atoms couldn't be. I guess I knew that atoms, if you had a atomic theory, then that couldn't surpass string theory, and then in string theory you don't even have to work. Sorry, in anything past string theory, you essentially, or the relativistic wave function, you don't have to work. If you do recognize the object, then you don't have to work with those compositional effects where they have their slices. What I like to understand as just slices in matter. So my vision can only like my binoculars can only see this way. Monoculars can only see that way. You know, one D, 2D, or whatever. Like, but it's always that infinite of time. So yeah, somehow I was saying that, well, you know, since there's less relativity here and there's more relativity the closer you get to Earth, um, you know, I probably just got paradoxical. I mean, I would have just gotten paradoxical and said, well, it's moving faster, and that means that it's decaying faster because of the gas. But whatever I said, I was incorrect. So yeah, I don't really. I might just back out from the hourglass. But yeah, I might resign from hourglass theory.